Okay, so chapter 4, R30IB plus iRVision overview. The objectives of this chapter are to be able to identify the advantages of FANUC iRVision as opposed to anybody else's. Things kind of tooting their own horn here. Identify how a camera may be mounted. Hint, it is not with duct tape. And identify various iRVision processes. There's a whole bunch of them. Process overview. FANUC's iRVision is a machine vision system in which the hardware is built into all R30IB plus robot controllers. So the physical hardware is already in the controller. All you need to do is add the camera and necessary cabling. Okay. If you're using a standard coax camera, there is one port that you can plug into. If you need to run more than one coax camera, you have to buy the little multiplexer box, and you connect them. Connect the cameras to the multiplexer, and then the multiplexer to that single port on the controller. Okay. With the Gig E Ethernet cameras, plug them directly into port C on the Ethernet is built into the controller. If you need more than one camera, just use a regular old run-of-the-mill Ethernet switch, plug the cameras into it, and then it into the port C on the controller. Cameras are specifically designed to offset robot positions based on part movement. The camera will pick out what the X, Y, and R offsets are from what you said. This is where the part is, and this is what it looks like, and so on. FANUC iRVision is also useful in part recognition situations where the robot offset is not needed, such as inspection processes. So you have these two markers presented to the robot. You can say which one of these is good. Well, obviously the one with the cap isn't going to match the profile, so I would call that bad. That sort of thing. In the one of the recognition labs that we're going to do, we're going to program the robot to tell the difference between like Halls and Ricola, or Halls and Tootsie Rolls, something similar, but enough difference that you can see, yeah, it is definitely a different part. Vision processes are executed from the main robot CPU as opposed to using a separate processing hardware. So all of it is done within the robot CPU itself. That's why, well, that and because you would blur your image, but you can't be doing motion at the same time that you're doing vision. Well, if your cameras were fixed mounted, I suppose technically you could, but the way the controller processes the logic or the instructions is sequential, one after the other. So you can't program motion and vision at the same time anyway. Yeah. Some of the benefits of FANUC iRVision are our R30IB plus controller is vision ready. No dedicated computer is required. Setup may be performed entirely from the pendant, although it is a whole lot easier to do from PC. Screen is bigger, you've got a regular keyboard, you've got a regular mouse. Makes it lots easier to do. And all you gotta do is hook up via Ethernet, and it runs on a web browser. So it makes it real easy.
Do you use any computer for that that has an Ethernet port to it?
Yeah.
You just dial the IP on the device?
Yeah. You have to know what the IP is on the robot controller. Set your network adapter to the same network. Open up a web browser and just punch in the address for the robot controller. And then you'll select iRVision because there's several options. You'll see that when we get out there. It's also less hardware to purchase. The only thing you have to purchase extra is the camera and the cable. And maybe the multiplexer or an Ethernet switch if you need multiple cameras. Camera mounting. iRVision is incredibly flexible and affords the user many different configurations. Camera may be fixed mounted or robot mounted. Each different configuration can offer the user many advantages that will be discussed later. If the camera is fixed mounted whenever you create your frame, it is a tool frame, and whenever it is robot mounted, it is a user frame. Now, fixed mounted camera detects workpieces using the camera installed on a stand. The fixed camera will always snap in the same place from the same distance. While the robot transfers workpieces, iRVision can detect the other workpieces so the cycle time can be shortened. I use a sufficiently strong camera stand so that the camera does not vibrate. That is one thing that I noticed out here in our lab. You know, we have the CERT carts with a little air compressor on them. If you happen to be trying to do a vision instruction and the air compressor decides to kick on, it shakes the whole cart. So your image goes blurry like that. I can't find any parts. I don't see any solid edges. So I did have them hooked directly to the shop air, and then we had to move them for whatever event it was, and they never got hooked back up. So when we get serious about doing vision, we're going to hook back up shop air. We won't be using those stupid little compressors and shaking our cameras all around. Robot mounted camera. Robot mounted camera is mounted on the wrist unit of the robot. That allows J6, so it allows the camera to move through all the direction it needs to. And by moving the robot to different places, you can measure in different places with a robot mounted camera. So you can look here and here and here and here. All you gotta do is move the robot to the appropriate place. When a robot mounted camera is used, iRVision calculates the position of the workpiece based on the movement of the robot. So the robot knows where it is at all times because it has the pulse coder feedback on all the servos, and it knows based on X number of pulses per axis, it can calculate where in 3D space it is, because you said when you master the robot, you say that this position is 0, 0, 0, 0, 0, 0. X, Y, Z will be off control. Okay. So any movement from there is in reference to that position. Okay. It makes it real easy for the robot to figure out where it is in three-dimensional space. Camera must be mounted on the final axis of the robot. 6-axis robot must be mounted on axis 6. Camera cable moves according to the robot movement, so care must be taken to ensure the cables do not tangle. Out there, you gotta be really careful. We made them long enough that you shouldn't be able to twist it up, but you can get it into some positions where you'll either hit the camera on the robot arm itself or twist it up enough that you can pull the cable, which at the least is going to change the position of your camera. And it works, cable over camera. Vision processes, much like the flexibility of Fanic Vision, iRVision, the various vision configurations afford the user many options among the many types of vision processes. Each type of vision process can be used to meet many challenges found in an automation environment. Some, but not all, of the vision processes are a single view inspection, which good or bad. Single view vision process, everything you need to see fits in the field of view of the camera without having to move the camera. 2D multi-view, you have to move the camera or have multiple cameras to catch everything you need to. Since our cameras are all robot mounted, when we do the multi-view, we just have to move the robot. And what's really neat about it is you set it up whatever user frame you want, even if it's world, and you just move it through that single axis. So the orientation of the camera doesn't change, from here to here. And then it knows how far it's gone. So when it detects this edge, it knows it is, there, plus however much distance it moved, and then wherever the other edge is. So it can figure out how long so far it is with great accuracy. Single view inspection, there again, pass fail. If it can't find what it's looking for, say it's looking for good or bad, and it sees this, it'll say undetermined. I don't find anything that looks like that. Unlike normal vision process, its purpose is to provide compensation data for robot motion or offset data. Inspection process does not return any positional data of the found part. Just did I find it? Yes or no? If I did, is it good or bad? It doesn't really care where it is. It's not going to do anything with it other than tell you pass or fail. And it does actually put those overlays on the touch panel or the PC screen, whichever one you happen to be connected by. 2D single view vision process. It's a vision process to offset robot motion by measuring the two-dimensional position of the workpiece with a single camera. Both fixed cameras and robot cameras are supported, so it can do either one. As well as fixed frame offset and tool offset mode to provide positional compensation are supported. 2D single view vision process will return compensation data results in the X, Y, and R directions relative to the offset frame. So X, Y, and R. Multi-view vision process used to compensate 2D motion of the robot by detecting multiple positions of the workpiece. Process will support 2 to 4 images to gather compensation data. This is used when workpiece is too large to capture the entire image with a single camera, while the 2D multi-view vision process is the entirety of the part does not need to be captured across multiple images. So all you gotta do is capture this edge and this edge, or this edge and this edge, and whatever it is you're trying to find. If they're fixed, it knows you have to tell it how far apart the cameras are. If it's a single camera and camera's robot mounted, it knows how far apart the camera or the views are because it knows how far it moved. Okay. It doesn't care what's in the middle, it just knows, needs to know where this edge is and where this edge is. And then, you know, say the geometric center is also the center of gravity. You can say, you know, detect that edge, figure out where the middle is, pick it up and go. Compensation data is gathered by generating an average offset relative to the combination of the images. 2D multi-view vision process will return compensation results in X, Y, and R directions relative to the offset frame. Assignments. Please do quiz number 4. Vision overview, and remember that the quiz must be completed or you will be allowed to participate in lab activities.